Welcome to another session of Everyday Mathematics. Now, today's problem comes from MIT 2024 Integration B, regular season, and problem number 3 is the problem of our focus today, which is a definite integral from x equals to 0 to x equals to 1 of x squared times 1 minus x to the power 2024. So it's a very interesting problem. I hope you stick around and hang out with us as we try to solve it. So I'd like to also thank our subscribers. Thank you so much for the support that you continue to show us. It's all your support that we come here day in, day out to try and share with you what we have. Also, for first-time visitors, what we do at Everyday Mathematics is we just go about and around and look at problems. We try and solve them and then come back and try and share with you the solutions that we have for them. And to our repeating visitors who haven't yet subscribed, we do really encourage you to consider subscribing to our channel. Your support will go a long way in giving us extra visibility we need. So this problem, I would use integration by parts. I like it because this is a very straightforward and easy to understand methodology. So what you do is, as I said, use integration by parts, where if you have a product of v du integrated, that would result into uv minus the integral of u dv. And so for this problem, if we consider v to be x squared and then du to be 1 minus x to the power 2024, then it means that u is negative 1 over 2025 times 1 minus x to the power 2025. So our integral v du, which is x squared times 1 minus x to the power 2024, integrated from x equals to 0 to 1 is it's uv, which is obviously this x squared times this u bounded between 0 and 1 plus, because this negative sign here interacts with this, we have a plus, the derivative of v, which is 2x, so 2 comes out, 2 over 2025, the integral from 0 to 1 of x times 1 minus x to the power 2025. Now, focusing on this uv part, this is the same as limit of x tending to 1 of this minus limit of x tending to 0 of this. Now, when x tends to 1, 1 minus 1 is 0, so this part goes to 0. So this part goes to 0. And then when x tends to 0, since this goes to 0, this entire part also goes to 0, right? So we're left with the integral of 2 over 2025 times x times 1 minus x to the power 2025, right? Then again, using integration by parts by setting v be equal to x, and then du being 1 minus x to the power 2025, that means that u in this stage is negative 1 over 2026 times 1 minus x to the power 2026. So now taking this integral all into account, it means that getting the constant where it is, our uv is x times this, which is negative x times 1 minus x to the power 2026 over 2026, obviously with the bounds 0 and 1, and then plus, again, this negative here interacting with the negative uv minus the integral, so this becomes positive. 1 over 2026, the derivative of v, which is x, is 1. So we just now have a bare integral of 1 minus x to the power 2026. So still, again, considering the limits, 1 and 0, as x tends to 1, as we can see, 1 minus 1 is 0. So this part tends to 0. And then as x tends to 0, this x here tends to 0. So this entire part also tends to 0. So we are left with the integral of 2 over 2025 times in bracket 1 over 2026, integral from 0 to 1 of 1 minus x to the power 2026. So if we integrate this 1 minus x to the power 2026, that's the same as negative 1 over 2027 times 1 minus x to the power 2027. So with the limits taken appropriately, we can see that as x tends to 1, 1 minus 1 is 0, so this part tends to 0. This tends to 0. And then as x tends to 0, so this is 1 minus 0. So this tends to 1 over 2027, negative and negative, this becomes a positive. So we have 2 over 2025 times 1 over 2026 times 1 over 2027 as our answer. So this is how I would solve it, because I like taking it from the very foundational aspects of things, from the first principles. But most folks would look at this problem and then say, hey, why don't you use beta function and then gamma function? So that's what we're going to look at here. So we're going to use a beta function for a second way of trying to attack this problem. And picking from Wikipedia, the beta function of z1 and z2 is the integral from t equals to 0, t equals to 1 of t to the power z1 minus 1 times 1 minus t to the power z2 minus 1. And so expressing our problem into this format here, that means that our z1 is 3, because 2 is 3 minus 1, and 2024 is 2025 minus 1. So this problem here can be expressed as a beta function of 3 and to the 25. Now, if we express this beta function in terms of gamma functions, because that's what would really help us to solve it, from Wikipedia again, if you have a beta function of z1 and z2, that's the same as the gamma function z1 times gamma function of z2 all over gamma function of z1 plus z2. So therefore, if our beta function is of 3 and 2025, then that's the same as the gamma function of 3 times gamma function of 2025 over gamma function of 3 plus 2025, which is the same as the gamma function of 3 times gamma function of 2025 over gamma function of 2028. Now, from definition, a gamma function of an integer n is the same as n minus 1 factorial. And so this problem here now becomes 2 factorial, 3 minus 1 factorial is 2 factorial. 2025 gamma function is the same as 2024 factorial over 2028 gamma function is the same as 2027 factorial. So 2024 factorial is 2024 times 2003 all the way up to 1. 2027 is the same as 2007 times 2006 all the way to 1. So you see that 2024 factorial cuts this denominator at 2024 factorial. So in other words, the denominator just becomes 2027 times 2026 times 2025. And then 2 factorial is the same as 2. So this is your answer, 2 over 2027 times 2026 times 2025. And this is our answer. Thank you so much for hanging out with us. It's been an absolute pleasure solving this problem with you. If you have any question, please don't hesitate to leave a comment in the comment section. We do look forward to interacting with you. We love mathematics. Mathematics is our passion, and we like to share that passion with you. Thank you. Until next time, at Look, Allah Adios.